All right. So yes, we probably have about 30 problems. Okay. For the test on next Friday. That's our first test. It will be from 1 to 150. Um, so are you talking about the quiz or test?
I was
When
talking
you
about the quiz that we had Wednesday, I believe.
okay, yes, you can make up later, but remember, you're gonna get a little discount, like not discount, but uh, you'll be taken off like 10% from the score you make when you make up. Uh, but yes, you can make up. So try to get the yes. I think okay. That's one thing I want to say. The grace period will probably ends this week. So you do need to buy the X code. So everybody, please buy the X code real quick and make it work because in the next week you're going to do the test and uh, you cannot do it if you don't have access code. All right. So that's the thing I really want
Hey,
to
access code.
I want to stress. Okay. What's the question?
Can you buy my access code? Because I'm not paying that
No,
much.
no, no. I can't.
You ain't
But
gonna
Okay.
get
I just take my test today because my little 3 days gone, man.
You need to buy it yourself, sir. Okay. Any other questions?
I got a question.
Yes.
I since you feel me like that bit is kind of expensive. You want to go in?
What do you mean?
I mean, like go in on the money and buy the access code.
No, no. You buy it. You buy the S
Or
code.
be
Okay.
welcome
That
Please
bit
for
don't
the
don't
team.
expensive.
ask me this kind of questions. Okay. Um, that's not the question. All right. Uh, let's see. So just make sure it will cover materials from P1 to P5. Okay, as wrote in the email. The first test. So you do need to buy the Xcode real quick, and what you need to do is you buy Cengage Unlimited. Okay, please. Uh, I think we try to make a deal with them, and they lower the price a little bit. I think the price for us right now is 110.
it
Okay,
must be
after some deal, so
code on my
$110. And so and that's even cheaper than a book. You can use it for many courses. So that's not expensive at all. So please do it real quick. You buy Cengage Unlimited, and then you use the X code to create account in Cengage. If you already have an account, then I don't think you need to do that. But you do need to. I think some people have not done any quizzes. Then they do need to create account using Cengage and then uh, link your accounts in Cengage and in website. You need to do that. Okay. Okay. Wait. Okay, let me finish. Okay. Um, so you need to buy the Xcode, and then if you have not done that, if you have not done any quizzes, okay, then you do need to link your accounts in website and the Syncage to make it work, and then you just log in with the same way as you did from Blackboard, the 5 steps I wrote before and showed in the class. So, and that is very, very important, okay? Otherwise, you will not be able to take the test in next week. So that's one thing. I guess, any other questions? If we don't have any more questions, then then we will start the lesson. And again, I already started recording. And you please do not leave before I take the roll. Okay, if you're not sure, just ask me. So let me just see what we were last time. Okay, I don't know if okay. Let's see. It's breaking up. What do you mean by breaking up? You got a problem with the internet or something? Let me show share now. I want to share the. I want to share the. Okay, did we start the P5? I think we did. Okay, it's good. Going in and out. You got a problem with them? What? With the internet? Okay, I think we did this page too. I think we did this one too, right? Yes, I think we did the example. You can hear. Yeah, log out and log in. Okay, log back in. So this is what you need to do because it happens sometimes. Okay, I think we did the last page. Multiply rational expression. All right. I think we did this example, if I'm right. So let's just continue this topic. Please don't do that, okay? We're gonna continue with operations with rational expressions. So we talk about multiplication with
Excuse me,
rational
before you
expressions.
start,
Yeah.
when you posted the PowerPoint slides, it don't show the full screen like this. It's cut off.
Oh, you download it. You download it.
I don't who?
The slides. You're talking about the
Download
slides,
it.
right?
Download it.
Yeah, download it. Download it. And then you can open it to the PowerPoint. You need to download it. Yes. All right. Okay, so let's talk about it. Yes.
You said download what?
Download the slides for the PowerPoint.
Oh, I bet.
Yeah. Okay. So let's talk about divided rational expressions. So you just use the same rules with fractions. As if you were divide the fractions, and you need to flip the divisor. Okay, so we need to divide in this example x cubed minus 8 over x squared minus 4 by x squared plus 2x plus 4 over x cubed plus 8. Okay, so you're going to flip the divisor, and so you get x cubed plus 8 over x squared plus 2x plus 4 to multiply the first rational expression, x plus 8 over x squared minus 4. So it becomes a multiplication, and then you just factor each part in each expression, then try to cancel factors, on the top and at the bottom. So you can factor x cubed minus 8 as we did before, so x minus 2 times x squared plus 2x plus 4 if we use the formula for difference of two cubes. You can rewrite 8 as 2 cubed and then use that formula to factor x cubed minus 8, and you get that. And at the bottom, x squared minus 4, you can rewrite it as x squared minus 2 squared. 4 is 2 squared. And use the formula for the difference of two squares. And you get x minus 2 and x plus 2. Similarly, for x cubed plus 8 in the second expression, you can use the sum of 2 cubes to factor them if you rewrite 8 as 2 cubed. And what you can get is x plus 2 times x squared minus 2x plus 4. All right, and you cannot factor anything over the denominator, x squared plus 2x plus 4. So just leave it. And then you find the x squared plus 2x plus 4 is a common factor on the top and at the bottom that can be cancelled. Also, x minus 2, as you see, can be cancelled. And x plus 2, 2. Okay, so at the end, everything will be cancelled except for x squared minus 2x plus 4. So that's the final answer. And obviously, x cannot be positive or negative 2. because you got x squared minus 4 in the denominator to start. So that's one thing just to be keep in mind. All right. So that's division of rational expressions. Okay, and then sometimes you may need to, and a lot of times actually, subtract or add the rational expressions. Just do the same thing as you do fractions. How do you add or subtract fractions? The first thing to do is find the least common denominator. Okay, LCD. So in this case, you just multiply the two denominators we have in this problem. In the first part, you got 2x minus 1, and then in the second part, you get x plus 2. So the least common denominator is 2x minus 1 times x plus 2. And then you can rewrite each term in this problem by using the least common denominator. So we do the first term, you're going to multiply x plus 2 over x plus 2. All right, just like the same thing you do fractions. Now you multiply expressions instead of numbers, but the way to do it is always the same. Okay. The second term, you're going to multiply 2x minus 1 on the top and at bottom at the same time. Then you're going to have the same denominator, and you can subtract the numerator. Okay. So you got the same denominator of 2x minus 1 times x plus 2, and then in the first term, if you multiply x with x plus 2, you're going to get x squared plus 2x if you distribute x and 2x plus 2. And in the second term is 1 times 2x minus 1. That's just 2x minus 1 itself. Okay. And then you just simplify the top. Distribute the negative sign to 2x minus 1. So we got x squared plus 2x minus 2x plus 1, and 2x cancels on the top. So at the end, you got x squared plus 1 on the top, and the bottom keeps the same, 2x minus 1 times x plus 2. And you cannot simplify this thing further. So that's the final answer. Okay, so that's how you add and subtract the rational expressions. Okay, you can do the same thing if you more than 3 terms to add for rational expressions, like in this example. In this problem, we have 3 terms. We got 3 over x minus 1 minus 2 over x plus x plus 3 over x squared minus 1. Okay. So again, the first thing is to find the least common denominator. Okay. So just imagine you have 3 fractions to add or subtract. Find the least common denominator of all the terms. And to do that, you're going to need to factor the denominators. And we have x minus 1 and the x, they cannot be factored, but the x squared amount can be factored. Okay, that's all we have. And that can be factored as x minus 1 and x plus 1 if we use the formula for difference of 2 squares. So in this case, it would be x squared minus 1 squared. Okay. So then we get the x minus 1 times x plus 1. And then you just look at all the other denominators, x minus 1 and x. So then you just multiply them out. You get the x minus 1 times x plus 1 times x. And you don't have to multiply x1 2 times because it already appears in one denominator. You don't have to multiply 2 times. Okay. So that's the LCD, x minus 1 times x plus 1 times x. Okay, then you rewrite each term of the problem by using the least common denominator as we did before. So what we do, in the first term, we got 3 over x minus 1. So we're going to multiply x plus 1 times x, both on the top and at the bottom. All right. In the second term, 2 over x, so we're going to multiply x minus 1 and x plus 1 on the top and at the bottom. And in the third term, we got x plus 3 over x squared minus 1. So the only missing part is x. So you're going to multiply x over x. Okay. And then we got the same denominator. All right. And then we can add or subtract the numerator. All right. So remember, x squared minus 1 is x minus 1 times x plus 1 in the third term in the denominator. All right. So then you got to multiply 3 with x plus 1 times x in the first term, and then you subtract the 2 times x minus 1 times x plus 1, and in the third term you just add x plus 3 times x. Okay, so now we got the same denominator, x minus 1 times x plus 1 times x. And then you simplify the top of this whole thing by distributing the numbers and multiply out. Okay, so in the first term, we got the 3 times x plus 1 times x. If you distribute this 3 and x to x plus 1, you're going to get 3x squared plus 3x. And if you multiply x minus 1 with x plus 1 in the second term, you get the x squared minus 1. And then you're going to distribute negative 2. So that will become negative 2x squared plus 2. Okay, you have to change the signs, right? And multiply. The third term is just to get x squared plus 3x if you distribute the x to x plus 3. And then you just combine like terms on the top. 3x squared minus 2x squared, you get x squared. But then you add another x squared, so that becomes 2x squared. And then you get 3x plus 3x, so you get a 6x. And then you add 2, and that's all. And there's nothing you can factor on the top to cancel anything at the bottom. So that's the final answer. All right? So it takes a little more effort if you have more than 2 terms. Okay. Now let's talk about complex fractions and the difference quotient. We're going to talk about complex fractions first. I think we learned this before if you in high school. Fractions, complex fractions. What does it mean by complex fraction? It means you have a fraction, but the numerator or the denominator of the fraction is a fraction itself, or both. So like in this example, we got the fraction, but then both the numerator and the denominator are fractions themselves, right? So how do you do this kind of problems? There are 2 different methods to simplify this kind of problem. The first method is just do the top and bottom separately. So like in the example in here, we got the 1 over x plus 2 plus 1 at the top. Then we can add those 2 by using the least common denominator, which is x plus 2. And you rewrite 1 as x plus 2 over x plus 2, and then you just write 1 with x plus 2 on the top. So you get x plus 3 over x plus 2, right? So that's the numerator. And in the denominator, you get x over 3 minus 1. So we can handle it separately by, using the least common denominator, 3. So you write 1 as 3 over 3, and then you subtract the x minus 3 and divide by 3. All right. So then, just like before, when you divide, by fraction, you flip it. So you just multiply x plus 3 over x plus 2 by 3 over x minus 3. All right. So then you just multiply the top with top and bottom. So you get 3 times x plus 3 over x plus 2 times x minus 3. So it's nothing you can cancel in here. So that's the final answer. By the way, when you multiply numbers with expressions, you usually put the numbers in the front. Like in this example, you can put 3 in front of x plus 3. All right? That's just a convention. So that's the first method. You deal with the numerator and the denominator separately. Okay, there's another method to do the problem. So we still doing the same example, but we're going to use a different method. Okay, so this method is to find the least common denominator of both the top and the bottom. So on the top, we only have x plus 2 as the denominator, and at bottom we only have 3 as the denominator. So what we're going to do is you just multiply these two LCDs, and then so we got 3 times x plus 2. All right. So we just multiply 3 times x plus 2 both on the top and at the bottom of the whole thing. All right. So as you can see here, so to do that, you're going to distribute 3 times x plus 2 to every term on the top and at the bottom. So you're going to get 1 over x plus 2 times 3 times x plus 2 plus 1 times 3 times x plus 2 on top. And then you get x over 3 times 3 times x plus 2 minus 1 times 3 times x plus 2. Okay, see? And then this will cancel all the fractions. So that's the huge advantage of this method. So on the top, in the first term, x plus 2 is canceled. So you only get 3. And then you can simplify 1 times 3 times x plus 2 by distributing 3, you get 3x plus 6. At the bottom, in the first term, the 3 is canceled. So you're left with x times x plus 2. And in the second term, you got 1 times 3 times x plus 2. And that's just 3 times x plus 2. Now you can further the whole thing by simplifying the denominator. Just distribute the x to x plus 2, so you get x squared plus 2x, and distribute negative 3 with x plus 2, you get negative 3x minus 6. Now you can simplify the denominator by combining 2x with negative 3x to get negative x. So you get 3x.
Ain't Miami is the East, ain't it?
Can you switch off the
Lakers and
microphone
somebody else.
when you
Lakers games. Hold up.
Can you switch off your
Oh, they're playing the Nuggets.
yeah when we were,
Yeah, I think so.
doing the lectures?
It's gonna
Please
be
turn
Heat
it
and the
off.
Lakers, bro.
Please turn it off
Mhm.
when we are in the
Yeah.
lectures, okay? Please. So you simplify the top and the bottom, okay? So the bottom becomes x squared minus x minus 6. And at the bottom, you can combine 3 with 6, you get 9. So you get the 3 plus 9 on the top, and then you can factor them like if you factor 3 on the top, you get 3 times x plus 3, and if you factor bottom, you get x plus 2 minus 3, okay? Using the method we had before. You just find two numbers. If you multiply them, you get negative 6. If you add them, you get negative 1. So these two numbers are 2 and negative 3. So that's this example. The second method. So you can use both methods to do the same problem with complex fractions. And which method do you like? It's up to you. As long as you get the right answer, it really doesn't matter which way you do it. Okay. Okay, so now let's do some examples for fractions. This time we got the negative exponents, and they are fractions also. So that becomes a little more tricky. So then in this kind of problems, we need to rewrite the terms in different format. That's usually the way to do it. So in example, we need to simplify the expression of x times 1 minus 2x to the negative 3 halves plus 1 minus 2x to the negative half. Okay, so you can see there is a common thing of 1 minus 2x, but there are in different exponents. So so that means you're going to need to rewrite, okay, a little bit. So what you do is you keep the first term unchanged, x times 1 minus 2x to the negative 3 halves, but you rewrite the second term as 1 minus 2x to the negative 3 half plus 1. Okay, so it's a negative 1 half. You can rewrite it as negative 3 half plus 1. And the reason why we do it is then you can factor a common factor 1 minus 2x to the negative 3 halves. Remember, um, you need to get the same exponent to factor out. Okay, so if you factor 1 minus 2x to the negative 3 halves, you are left with x for the first term, and you're left with 1 minus 2x to the 1 in the second term. See, and that's how you factor expressions. Okay, so then 1 minus 2x to the 1 is just 1 minus 2x. And you can combine x with 1 minus 2x to simplify it to get 1 minus x. And you still have the factor 1 minus 2x to negative 3 halves in the front. So you can, you write this whole thing in fractions, okay? Remember, the negative exponent means you put the whole thing in the denominator. So 1 minus 2x 3 halves in the denominator. So that becomes that. But the 1 minus x is still on the top. Okay, so the final answer will be 1 minus x over 1 minus 2x to the 3 halves. All right. So that's the small trick that we usually use quite a bit when we combine rational expressions with different exponents but the same base. Okay, like 1 minus 2x in here. Okay, let's do some examples simplifying rational expressions. So we're going to do this problem with fraction exponents in here with the same base but different exponents. So this becomes even more complicated. We got another fraction, and the numerator of the fraction also have some exponents, fraction and negative exponents with the same base. Okay, and you can do it in different ways, but one of the easiest way, okay, to do it, to make it neat, make it clean, is to multiply x squared minus 2 to the half. All right, we got the x squared minus 2 to the negative half in one term in the top. So we can multiply x squared minus 2 to the half, positive half, both on the top and at the bottom to take care of that negative half exponent. Okay, so to do that, you're going to distribute x squared minus 2 to the half to both terms on the top. So that becomes x squared times x squared minus 2 to the negative half times x squared minus 2 to the half plus x squared minus 2 to the half times x squared minus 2 to the half. So that's just distributed x minus 2 to the half on the top. And at bottom, you get the x squared minus 2 times x squared minus 2 to the half. Okay. Now, on the top, when you multiply two expressions with the same base, you're going to add the exponents. So in the first term, you're going to get x times x squared minus 2 to the negative half plus positive half. All right. And in the second term, you just get x squared minus 2 to the half plus half. Add the exponents with the same base. All right. And at the bottom, we got x squared minus 2 to the 1 plus 1 half. Remember, when you don't have anything in the exponent, it means the exponent is 1. So x squared minus 2 is just x squared minus 2 to the 1. So that's why you get 1 here. So just do the step by step. Negative half plus half is just 0. So we get x squared times x squared minus 2 to the 0 in the first term on the top. And half plus half is just 1. And so we get x squared minus 2 to the 1 for the second term on the top. At the bottom, 1 plus half is 3 halves. You can rewrite 1 as 2 over 2. So you get 2 plus 1, which is 3. So you get 3 halves as the exponent. So that's x squared minus 2 to 3 halves. Now, x squared minus 2 to the 0's power is always 1. Okay. Anything to the 0's power is just 1. So then it's left with x squared on the top for first term, and then x squared minus 2 to the 1, it's just x squared minus 2. All right, and you keep the denominator unchanged. So now you can combine the like terms on the top, x squared plus x squared, just 2x squared, and then you get the negative 2. And in the denominator, x squared minus 2 to the 3 halves, and there's nothing to cancel. You cannot simplify it. So that'll be the final answer. All right. So it becomes a little more complicated, okay, in this kind of fractions. You can call it complex fraction, but it's even more than that, okay? Okay, there's one thing we want to talk about in the last part of this section. It's called difference quotient. It's involved in rational expression, but also we have radicals in here, okay? And the difference quotient is defined as this: square root of x plus h minus square root of x over h. Okay, this is called the difference quotient, and you're going to see that in Math 112 and calculus if you take a calculus, and that will be related to the slope with some tangent lines, secant lines. Okay, but this thing is called the difference quotient. Square root of x plus h minus square root of x over h. And usually we need to rationalize the numerator of this difference quotient. All right. So that means, if you still remember what it means by rationalizing the numerator, it means we need to change the form of this expression, and so that there will be no radicals in the numerator. All right. So we need to get rid of radicals in the numerator and keep the h unchanged. You cannot change the problem. Okay. So remember, whenever we have these kind of problems, we always multiply the conjugate of the numerator. And the conjugate of the numerator is defined as square root of x plus h plus square root of x in this problem. Okay. So the conjugate is always changing minus to plus or plus to minus in any case. Okay. So you just multiply that conjugate both on the top and at the bottom. And that will take care of the numerator. All right. So let's just multiply this conjugate both on the top and the bottom. So at the bottom, you just get h times square root of x plus h plus square root of x. On the top, you get the square root of x plus minus square root of x times square root of x plus h plus square root of x. And you can use the formula for different squares. A minus b times a plus b equals a square minus b square. If you let a equal to square root of x plus h and b equal to square root of x, then you just get the a square minus b square, which is square root of x plus h square minus square root of x square. And obviously, if you take square root and you square it out, you get everything. The square root and the square cancel. So it just becomes x plus h in the first term on the top, and it's x in the second term. All right. So then you can cancel x on the top and just to get h. Now you can cancel the h on the top and at the bottom to get the 1 on the top, and square root of x plus h plus square root of x at the bottom. Here we have to require h not equal to 0 because the initial problem has the h at the bottom, so h cannot be 0. But the final answer is just 1 over square root of x plus h plus square root of x. All right, so that's the end of this section. We just finished it on time. I'm going to start a new section. We only have 2 more minutes. And we, as I said before, we have the test on next Friday. It covers sections P1 to P5. It's about 30 problems. The test will start right at 1 o'clock, and ends at 1:50 on next Friday. So just be prepared. You know, review all the slides and make sure you know how to do the examples without looking the answers. If you can do that, then I don't think you have any problem with the test. But you do need to get for the X code to buy Syngage code, Syngage limited, Syngage unlimited. I'm sorry, Syngage unlimited, about $110, and then you know. If you already done that, I think you just put in and activate your account. But if you have not done anything, you didn't use Syngage before, you didn't have account, you need to create an account using that X code and link the accounts with WebSign and then you can access WebSign from Blackboard as we showed in the class.
I have a question.
Yeah,
not really a question, but
yeah.
I'm trying to buy the code right now, and it's asking for my address.
You can,
address. So we don't need no address? I can type in my home address.
You can. I don't think it matters, but you can. Maybe it's good to use the address in the school. Since your school in school now.
It's just a digital code, right?
Yeah, it's just code, so it doesn't have any physical thing to mail to you, so it really doesn't matter. But I think it's better to use the school address.
All right.
And yeah, I think it should be $110. Okay, if you get.
Mine's 119, but okay.
Yeah, it was 119, but they agreed to reduce $10 for us as we negotiate with them. So just call them and tell them you're a student name, and they should give you that discount. And recently it becomes a little better for the call time now. You don't have to wait too long. It doesn't hurt to call them. All right. Any other questions? Did you take? Okay, good question. I'm going to do it now. Yes. So please don't leave. Let me just take the row. And we can still, I can still answer questions after taking the row. Okay, I already got the row now, so you can ask me questions if you want. So what's the next question?
Can you put this PowerPoint online?
I will. Yes, I will post it after the class. I will post it. Yes. Let me just okay. I don't know what else I want to say. Let me just stop recording.